Hi everyone, and welcome to Top 10 in 10 review videos for the AP Psych test. Today we're going to be talking about the research methods unit, so let's get started. So, first thing, common sense is not so common, right? There are a couple of things that you need to know in terms of why we need research. I mean, you could go on for this for hours, why we need research and why we just can't say, oh, psychology is common sense. There's a few key ideas. One, overconfidence. You tend to feel like you are better than you actually are. Sorry, I don't mean to break your heart, but that's the truth. Hindsight bias. So once you know the answer, you feel like you always would have known it. That's not true. You only know it because I told you. And confirmation bias. This is where you only look for information that confirms what you already believe to be true. So if I believe that changing your answer on a test is wrong, then changing your answer on the test will then lead to you getting it wrong, then you only remember the times when you changed it and got it wrong. But all the times that you changed it and got it right, you didn't remember that. Instead, you were like, ha, look how smart I am, right? When you saw the test. So 3 main reasons why common sense is not so common and we need research. Different types of research methods. So psychologists study a lot of different things, and we can't just use one method to study everything. So you need to know the different methods, and you need to be able to differentiate between them. That means that you need to know which method is best for what kind of research, and you need to be able to say the strengths and the weaknesses. So naturalistic observation, right? Just like it sounds. You observe people, animals, whatever, your subjects in a natural environment, okay? You are supposed to be invisible, right? And remember here, you really get, you get out of the laboratory. So laboratory can be kind of artificial, doing an experiment in a lab. So you get that natural kind of environment, but there's lots of room for error, there's no control groups, and you have to make sure that you and me are rating things exactly the same. Inter-rater reliability. Case study. Awesome if you're studying something that's extremely rare, or if you're just wanting to get a really in-depth, detailed explanation of something, okay? Of course, the strengths are all the details, the depth, the information you get, but the weaknesses, it's not generalizable, right? Because you just have a lot of information on a little sample. Survey, right? Surveys are used all of the time, okay? I don't know how many surveys you've filled out in your life, but I know I filled out a ton. Important things to remember about surveys. 1, the wording effect. So how are you writing your questions, okay? The way you write your questions can determine the way you get your answers, and so they can also determine your results. Second, who are you sending your survey to? Is it a representative sample? So you have your population, and then you have to send it to a representative sample. Okay, and then they send it back. It's also important to think about how many of the original surveys did you get back. If you sent out 1,000 surveys and you only got back 100, well, your results might not be that great. And then correlation, right? And here's the thing. We all know correlation does not equal causation. And we also know that will be on the AP test. I mean, maybe not that exactly, but there will be something that forces you to identify experiments as cause and effect, or correlation as not causation, right? Or any of the other ones, any of these 4, naturalistic, case study, survey, correlation. You cannot determine cause and effect. The only way to determine cause and effect is with an experiment, because you have a controlled research, you have a control group and an experimental group. So then you can measure the difference between the two, okay? Some points of caution. Like I said, correlation does not equal causation, and surveys used for correlational research are different than surveys used to measure the dependent variable, okay? So you can do a survey for a survey's sake, right? You can hand out a bunch of surveys on who people are gonna vote for or what they think or whatever, drug use in schools, whatever, right? You can do any of those things. That's the survey method. But sometimes psychologists will actually use surveys to measure the dependent variable. Samples. It's very important that you understand samples, populations, representative, and random. So there's lots of different things that come with this, okay? Now, the population versus the sample. The population is the entire group you want to understand, okay? A lot of times that group is human nature, right? The human population. We try to determine something about humans in general. And then the sample is the group that you pick the population from. Now, the thing about psychology, like I have over here, is that psychology is weird, which means that the majority of our subjects are Western, educated, industrialized, rich, and democratic, right? The population that we get most of our studies from are college students in the United States or in other westernized cultures, okay? Now, is that really indicative of the entire, human culture? No, right? So psychology is kind of weird. So now it needs to be, you have your sample. Now it needs to be random and representative. You don't get to pick. So representative means that you have to have a equal percentage based on the population. So you can't just have juniors and seniors. Even in your study, you have to have freshmen, sophomores, juniors, seniors if you're going to do representing Mundelein High School or any other high school, whatever. And then it has to be random. So the order with which you choose your subjects cannot just be the first 25, the last 25, whatever. It has to be completely random, okay? Make sure you know the difference between random and representative. Okay, parts of an experiment. Independent versus dependent variable. So what does the experimenter change and what changes because of the experiment? Okay, independent is what the experimenter changed. Dependent is what changes because it's dependent on the independent. An operational definition, right? I don't know why, but for some reason, this tends to trip students up. Definition, you go to Webster's dictionary, you pull it out, you look up the definition, okay? So an operational definition is a definition of how the variables were basically how the variables were used in the study. So, for example, if in my study I'm talking about aggression, I have to define aggression. Yours and mine will be different. So the definition that I'm working with in my experiment, which can be whatever I want as long as I'm clear about it and it's specific, is my operational definition. And I need this so that if you want to redo my study, you can redo it and show that the results are consistent. Next, we have the control versus the experimental group, okay? This is very, 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 very important. This is what makes the experiment different. You have two groups. One group gets the independent variable, the other group does not. The control group does not get the independent variable. And then random sampling versus random assignment. So, like I said, you have to choose a representative sample. Then your sample has to be random, right? So from the representative people, you have to choose them randomly, right? And you can do the random and the representative piece simultaneously. But then you take your random representative sample and you turn it into a random assignment. So you randomly take this group that you're working with and either put them in the control or experimental group. Doing this, right, gets rid of the intention is to get rid of confounding variables besides the independent variable that will mess up your results, okay? This will be on the test in some shape or form. So it is very important that when you're talking about random assignment, you are specific in that you address two groups. Do not get tripped up by talking about something as representative or random sample, right, or representative group when you mean random assignment. Two groups. Control and experimental. Okay, in research, although we try to be really good about making it, bias-free, that's obviously pretty much impossible. So here's a couple different ways that you can get rid of bias or limit it so that it's not such a huge part of the results. So in terms of drug trials, placebos, right? The placebo effect, is when you take something. We talk about this a lot with drugs, so that's what I'll just use. So you get better because you want to get better, right? And so what we'll do with groups, we'll have the experimental group, the control group. The experimental group will take the real drug. The control group will take the placebo, right? And then sometimes you have another group that gets nothing, and then you might measure all three. If the group that took the placebo gets better, then you have to wonder how much of the group that took the pill is actually based on just the fact that they wanted to get better, right? So this is why it's very important that we use placebos in measuring drugs or in doing experimental, trying experiments on new drugs, coming up with them. Okay, double-blind and single-blind research. So who knows what's going on in your experiment? Generally, the participants don't know, right? Now, they know the general idea that gets into informed consent, but they don't know the hypothesis. When I say they don't know, that's what I mean. They don't know what it is you're exactly trying to study. If the participants don't know, but the researcher does know, it's a single blind. But better than that is if the participants don't know and the researcher doesn't know. That's a double blind. And remember, the researcher could be the person in the room actually giving out the surveys or asking them to do the different thing or giving them the plates or whatever they're trying to do. Who knows, right? That doesn't mean there isn't another researcher who maybe it's like the big guy on top and then the graduate students in the room who does know the hypothesis. But if he tells his grad student, maybe the grad student might be more likely to say something, not even intentionally, that might bias or skew the results. So double blind. Okay, what are the ethics, right? So we focus a lot on human ethics. So informed consent. I know I am here and I can stay or leave at any time. Free from harm, physical, psychological. Confidentiality. Do not put names, no names, right? And then debriefing. You have to make sure, especially if you are hiding parts of your hypothesis in the informed consent piece, that you have to be very good about debriefing and explaining what the purpose of the study was. Okay, here we go, stats. All right, correlational coefficients. Okay, it's very important. Like I said, correlation does not equal causation. But when you do correlational research, you do descriptive statistics. So you take what you find and you come up with a way to summarize the data so that it's meaningful. So a correlational coefficient has two parts. It has a positive or negative sign. This tells you how the variables are related. If one variable goes up, does the other go up? Or if one variable goes up, does the other go down? If they both move in the same direction, it's a positive correlation. If they move in the opposite direction, it's a negative correlation. And you can tell this too by the slope of the line, would be positive or negative if you did a line of best fit in these samples down here, okay? Then you have a number from 1 to 0. 1 is like a perfect correlation, okay? Doesn't really happen in nature all that often. So, and then normally you'll have like a 0.75 or a 0.5 or a 0.2. You know, if it's, I think a 0.3 and below, you don't really have much of a correlation. In the 0.5 range, pretty good. 0.7 and up, the correlation gets stronger and stronger. And you know, positive, same direction, negative, opposite directions. Okay, so skewed distributions, right? We're going to go to normal distributions in a second, but skewed distributions are important because you need to know which way the skew is. And I know it's very confusing, counterintuitive, it doesn't matter, you can do it, focus, right? So you focus on the tail. Where is the tail, right? So if the tail is in the higher numbers, it's a positive skew. If the tail is in the lower numbers, it's a negative skew. Remember, and in this instance, you don't want to use the mean because it's affected by outliers, right? So it's not the best measure of central tendency to use in a skewed distribution. Median generally tends to be better. Okay, standard deviation and normal distribution. So if you see over here, right, we have this again. This is kind of covered. You can't really see it, but here you have the positive skew. And here's where you have normal skew, mean, median, mode, all the same, right? Down the center. This is very important. 50% of the results are on one side or the other. And then over here, we have your standard deviation. So we have 68, 95, 99, okay? And then remember, you can even break it down even more to know these percentages if you need to add or subtract. On the AP test, they will most likely ask you a couple of things about this. They'll make you something with intelligence. You need to know the standard deviation of an intelligence test, or the mean of an intelligence test is always 100, and the standard deviation is always 15. If it's not an IQ test, they will give you the mean and the standard deviation, okay? You need to know that the larger the standard deviation, the more spread out the results are, okay? And you also need to be able to tell me how many people fell above or below that place in the graph. So that's where the 68, 95, and 99 comes into play, okay? And last but not least, p-values and statistical significance. So descriptive statistics are meant to describe the data in a visual form. Yeah, you have tons of numbers. What does that mean to me? Nothing. So I need to somehow put it together so I find meaning. Inferential statistics is then you actually see if what you came up with can be used to infer or like to learn things about the entire population, right? If you can actually use the results in a way that they are meaningful, that they mean something about a group of people, okay? With inferential statistics, you have statistical significance and p-values. The p-value is that 0.05 that we talk about in psychology, that the p-value should be less than 0.05, and that 0.05 turns into 5%, and what that means is that there's less than 5% chance that your numbers, all your data, all your results are not just completely random chance answers. It didn't just happen that way. All right, so that's all for now, AP Psychos, and remember, psychology is flippin' awesome.